Okay, in this lesson I want to continue our work on revisiting friction. In this case we have a particle on a horizontal plane. I want to complete the force diagram for this particle. So I've got various things going on here. I've got the weight of the particle traveling downwards, that's the force on the particle by gravity, that's 100 root 3 newtons. I have this tension force here, this 10 root 3 newtons pulling along here on some kind of rope. I've got a coefficient of friction. I want to complete the force diagram. So what is happening here? Well, the object is in contact with this horizontal plane. So anytime it's in contact, there's some kind of contact force. The force on the particle by the plane will be perpendicular to the plane, and we call that the normal reaction. Now we have to be a little bit careful here because the up forces, if it's traveling on a horizontal plane, will equal to the down forces, and the down force is still just the weight. However, the normal reaction is no longer the only up force here. This tension is a bit up as well, so that's going to reduce the normal reaction. So we'll come back to that in a moment. Also, we can see there's a coefficient of friction here, so there's going to be some force that I'm going to call F here to the left. Okay, there's my force diagram complete. Okay, now I'm going to see if I can work out values for this friction force and for this normal reaction. So what I'm going to do is I'm going to try to resolve this tension force so that it's parallel and perpendicular to the plane. So I'm going to resolve this tension force here, parallel to and perpendicular to the plane. Okay, it's a little right triangle. Opposite is always hypotenuse times sine of the angle. However, if you know your special angles, you should know the side opposite 30 in a right triangle is always half the hypotenuse. That will be 5 root 3. Okay, so that's going to be 5 root 3 upwards. Also, the side adjacent to the 30 is always it's always hypotenuse times cosine of the angle. But in a special triangle, like 30, 60, 90 triangle, it's always root 3 times that side opposite 30. So 5 root 3 times root 3 is going to be 5 times 3. That's going to be 15 newtons there. So it's kind of, that tension force is essentially pulling to the right 15 newtons and pulling upwards 5 root 3. So what is the normal reaction? I want to think about the normal reaction. Well, remember, the forces up are going to equal to the forces down. How do I know that? Because it's traveling on a horizontal plane. This is a string just pulling along here. That's just going to make it travel along the plane. Forces up equal to the forces down. The forces up here, well, actually there's two. There's the normal reaction, and there's this 5 root 3. So there are two forces acting upwards, and they have to equal to the force down, which is 100 root 3. So what am I adding to 5 root 3 to get 100 root 3? Well, the normal reaction has to be 95 root 3. So the normal reaction here is 95 times root 3. Not 100 root 3. It's not the same. Combined, quick check, combined, the upward forces have to equal to the downward force. The friction force here, when we have to think about it for the moment, we know that the maximum value for friction is mu times r. So the maximum value for friction will be 1 over root 3 times 95 root 3. So friction can get up to 95 newtons if it needs to. That's the maximum possible value for friction, is 95 newtons. Now, will it be 95 newtons here? Well, no is the answer, because to the right there's a force pulling of 15 newtons. Friction doesn't create motion, it only opposes motion. So it doesn't need to call on all that 95 newtons that it's capable of calling upon. So it's only going to get up to 15 newtons. So that's my force diagram here. So friction would be 15 newtons in this case. 15 newtons. It can get up to 95 if I increase that tension, well, the up component and the cross horizontal component will increase. Once this horizontal component increases, that's going to increase friction until such a time that friction can no longer increase, and that's the point at which we will get acceleration. Which takes us on to our next question, is find the least value of tension here for acceleration to occur. So very similar setup. We have a coefficient of friction of 1 over root 3. I have the tension force here. What are the other forces at work? Well, the force on the object by the horizontal ground, that's called a normal reaction, which I don't know just yet. And then we have some kind of friction force acting out to the left. The force that is not parallel nor perpendicular to the plane is the tension force. That's going to need resolving. So over here, t sine 30, hypotenuse times sine, or if you know your special triangles, just half of t. And the horizontal side here is going to be t root 3 over 2. It's always hypotenuse times cosine of the angle, or in a special 30, 60, 90, the side opposite 60 is always root 3 times the side opposite 30. So, a couple of things we're going to think about. Well, first of all, what is the normal reaction? Well, the normal reaction depends on the value of t, because the normal reaction plus t over 2 is going to equal to 100 times root 3. So the normal reaction is going to equal to 100 root 3, subtract whatever t over 2 is. So that's my normal reaction. It's in terms of t, meaning as t changes, so too does my normal reaction. Normal reaction is 100 root 3, subtract t over 2. So as t gets bigger, the normal reaction is getting smaller, and that should make sense, because as t is getting bigger, that's creating a bigger lift and reducing the pressure, the force between the particle and the horizontal plane. The maximum possible value for friction is always mu times r. That's 1 over root 3 times 100 root 3 minus t over 2. So the maximum possible value for friction is going to be multiplying out, distributing 1 over root 3 times 100 root 3, well, that's 100, and then minus t over 2 root 3. So that's the maximum possible value for friction. For acceleration to occur, we've got to pull this rope with such a force that friction maxes out. So in order for acceleration to occur, friction has to reach its maximum. 100 subtract t over 2 root 3. So, when will friction occur? Well, friction will occur when the force to the right here, the tension force, is greater than the force to the left, the friction force. So acceleration will occur if and only if t root 3 over 2 is greater than 100 minus t over 2 root 3. And this is a fairly straightforward linear inequality. Maybe I don't really like the fractions here. Maybe I'm going to multiply on both sides by 2 root 3. So just to kind of eliminate some of these fractions. So multiplying on both sides by 2 root 3. Notice it's positive, so I don't have to worry about the direction of the inequality. T over 2 root 3 times 2 times 2 root 3. Well, that 2 will cancel that. We get t root 3 times root 3. Well, that's going to be 3t. So 3t is going to be greater than, multiplying 2 root 3 by 100, that's going to be 200 root 3. And then subtract 2 root 3 by this quantity here, well, that's just going to leave me with t. Adding t on both sides will give me 4t greater than 200 root 3, which means dividing by 4 on both sides, t must be greater than 50 root 3. So in order for acceleration to occur in this system, t must be greater than 50 root 3. So for this system to accelerate, I have to throw in a tension here that must be greater than 50 root 3. Anything less than 50 root 3, it's not going to accelerate. Okay? So something to think about with friction. Notice the normal reaction is not just always equal to the weight. That's a very important thing to remember. I have to examine all the up and down forces to figure out what the normal reaction is in this case. Okay? So go through those, get a good idea of friction. We'll be using friction again in questions on work on power. So just a bit of a recap for today.